Long division. Hey, let's talk about old long division. So let's say you had like 356 that you were going to divide by 2. Well, does 2 fit into the 3? Well, it does once. So then you would be thinking to yourself, well, 1 times 2 gives me 2. And since 2 fits into 3 one time, you'd be ready to go, and you'd take that away, right? And this 5 comes down, and now you'd be like, well, 7 fits in it. So 7 times 2 gives me 14, which means I take that away. And then this one I don't have a remainder in, because things kind of end up nice. So let's remind ourselves of that, just because if you don't know how to do long division and why you do long division the way you do it, then you might find yourself in a little bit of a spot. Whenever we do a division problem, we need some room above the quotient bar. So here's the quotient bar, and I'm leaving a little bit of room here. If you don't plan ahead for that, that's fine. And I'm doing x squared plus 3x minus 24 divided by the quantity x minus 4. Well, how many times does just this leading term, x, because that's the largest one, the highest power, fit into x? So what would I multiply x by? That could give me x squared. So it fits into it x times. So if I write my x here, now I'm just like in old long division, I'm going to multiply by everything I see over there. So x times x gives me x squared, and then x times negative 4 gives me a minus 4x. But now comes the part where I have to take all this away. So I'm going to draw a line there, I'm going to subtract, but then that means I'm going to subtract a negative 4x, so it's like I'm adding 4x. So now that is a plus sign, because it had to change its sign. Well, my front x squared terms go away, and when I add 3x to 4x, I get 7x. But I still haven't dealt with this part, so I'll bring that down, and I'm going to write minus 24. So now I'm trying to see, well, how much of x minus 4 fits into this. So I picture x times what giving me 7x. Well, that would have to be 7. So x fits into 7x 7 times. So I'll sneak a positive 7 up here. And then I do 7 times x will give me 7x. Then I do a positive 7 times a negative 4 gives me minus 28. Then I set up my line again, and when I go to subtract it, it changes the sign on this value as well. 7x goes away, and negative 24 plus 28 gives me a positive 4. And now it's not like I can fit x into 4 because there's no x term showing up. So what this means is that my final answer is going to be the result of what happened when I divided, which is x plus 7, but I also have a little bit of a remainder left over, which is this 4. And I'm going to add that 4 onto the end, but this would be in the numerator because I still have not divided that 4 by x squared plus 3x minus 24. So that's the first problem of long division of these 3 that we're going to do, and we're dealing with polynomials here, so it's a little bit more intense than some of the long division you're used to. Let's check out a second problem. Here we have y squared plus 3y plus 12. And you have to budget for your space, so that's going to be divided by y plus 3. Well, how many times does y fit into y squared? Well, it fits in there y times. So I'll write a y, and then I combine and multiply. Y times y gives me y squared. Y times 3 gives me 3y. And then I'll subtract these, which means the signs change. My y squareds go away, and a 3y minus 3y ends up actually giving me 0. And this time I will write that, just so I know that when this 12 comes down, there's my 12. And, well, in the last one, nothing really disappeared in this term, so we still were able to try to fit in like a 3 to 3y, but in this problem, we're already done. So we jump to the result, which is going to be y, that's that y right there, plus our remainder of 12 over y squared plus 3y plus 12. Now, if I happen to make a mistake in these, you can probably trust yourself and just let me know later. There's a lot of room for error. Here's 3, and I'm taking 3x squared plus 9x minus 15, and go ahead and give this a go on your own. I'll go through it, but I'll go through it quicker this time. So try it on your own and then listen to what I have to say about checking it. I'll start now. Instead it fits in there 3x times, so there's 3x getting multiplied by x to give me 3x squared, but then also positive 15x. And then when I go back and subtract this, it ends up changing those signs. 9x minus 15x gives me a negative 6x minus 15. And then when I go through and I try to fit in to the 6x, well, it fits in 6 times, but really negative 6 times. So now I'm doing negative 6 times x to give me negative 6x, negative 6 times 5 to give me negative 30, and then when I go through and subtract it, these signs change, which means that those terms go away, which is perfect because that's what was supposed to happen, and I'm left with 15. And I don't know if I'm budgeting my space well enough to show that I'd really put my answer over there, so I'm stuck fitting it down below here, so here's 3x minus 6 plus 15 all over 3x squared plus 9x minus 15. And I guess you might look in the back of books and they probably would see that everything has a 3 that can fit into it, so you'd end up with 5 over x squared plus 3x minus 3. And that's these 3 problems. To avoid making this video extra lengthy, we will hang tight on this for another video. So give yourself a moment if you'd like to try some of these ones in a worksheet or in the spiral that don't involve long division with missing terms.